Okay.
You're better than?
Not quite.
Oh.
Hopefully you guys are getting the idea of putting your vectors together so that you can find a resulting vector and using component vectors and column vectors and all those things that we were introducing last lesson. Today's lesson is the dot product or the scalar product there in brackets, and we have a formula for you. If I want to multiply two vectors, so vector A times vector B, that's going to be the length of A times the length of B times cos of the angle in between them. Now I've put a little note there for you that theta is the angle between the vectors. I hope that's kind of obvious, but the bit that might not be obvious, because we've been spending so much time putting our vectors tail to tip, then tail to tip, to do the theta, they are actually when the two vectors are tail to tail. Okay, so you can see in the diagram that I've drawn there, vector A and vector B are tail to tail. And just for practice, what would be my resulting vector there in terms of A and B?
3.
No, that diagram there. It would be B minus A, very good. Because A needs to be turned around, because I was going from A to B in the direction of the arrow that I've drawn there. A needs to be turned around, so it's minus A, but the B is the right direction, so it's positive. That's not really to do with this lesson, but that's what we were doing last lesson. Okay? All right, so there is some things here that says for all vectors A and B and all scalars lambda. Okay, so you're going to see the lambda being used as the constant in some of these rules that we're about to go through. Now, the vectors are going to be perpendicular. So if they're perpendicular, A times B is equal to 0. And that can be found easily from the formula, because if you were to put in 90 degrees for the theta, what's cos of 90 degrees? 0. Okay, so it wouldn't actually matter what the length of A and the length of B are. If cos of the angle is 0, then multiplying them together is going to be 0. It does also say there, though, that vector A and vector B, if and only if vector A or vector B are equal to 0, or A is perpendicular to B. Okay, so you would also get 0 if one of the vectors itself was 0. The length of vector A times vector B is the same as the length squared. It also means that if you just wanted the length, you would square root vector A times vector A. Now these next couple of ones are things that should look very familiar from the things that you've learned in algebra over the years. So the commutative law means that vector A times vector B is the same as vector B times vector A, just like you would expect from normal algebra things. It doesn't matter the order in which you multiply them, they should still be equal. Okay? The associative law is to do with where you put the constant, lambda. So if I have lambda times by vector A times vector B, you can times the lambda into one of the vectors, so you could times it with A first, and then times it through to B. Or you could do it the other way around if you wanted to. You could times it into B, and then through into A. Okay, so it doesn't matter.
It's not the same as the commutative law?
Yeah, it's just putting a scalar in there as well. Yes. And saying that's not important, you can multiply it to one or the other first. It works either way. And the distributive law, which we normally associate with expanding brackets, and that's pretty much exactly what this is. If I'm wanting to multiply vector A with vector B plus vector C, you can literally just expand that out. So it's vector A times vector B plus vector A times vector C. So it's just good to know that the things that we expect from algebra still do work with our vectors as well. This last one, vector I, remember, is our unit vector on the x-axis. If you were to times that by itself, then you would simply get the number 1. Okay, unit vector means a length of 1, so timesing it by itself, you're just going to end up with 1, right? And it works the same for j, which is just on the y-axis instead. And since I and j are specifically letters given to the x-axis and the y-axis, when we multiply them together, they're going to be perpendicular, which means that they will also give 0. Okay? Yes? All right. Last little dot point. If vector u is the x1 times I, which just means some x value, that could be like 2i and plus y1 times j, so it's just a number in front of the j is what the x1 and the y1 represent. And vector v is x2i and plus y2j. Then we can multiply those two vectors together. And this is the part that doesn't quite follow what we'd probably want to do if we were doing like FOIL, for example. You think you've got two things there for vector u and you've got two things there for vector v. If you're going to multiply them together, the temptation is just to multiply the whole thing out. But you don't need to. You actually could. I'll explain why you don't need to in a minute. All you need to do is to times the x's with the x's, so you've got x1 times x2 there, so this is the formula. If I want to multiply u times v, I just multiply the two x numbers together, plus multiply the two y numbers together. The reason you don't need the two middle terms when you're expanding that out is because if I was to multiply, say, the first term with the outside term there, I'd have x1, y2, ij. I then have I and j times together, which makes 0. Okay, so you're never going to need those middle terms in that expansion because they're always going to make a 0. Yes? Good? All right. Yeah. All right. If you're writing them as a column vector, okay, so column vectors are those ones with the square brackets, then you'd be writing that down as your x1 value. Oops, I meant to have my highlighter there. My x1 value, my y1 value. And this is my x2, my y2, so just writing vector u and vector v as column vectors. And then you literally just multiply the two top numbers together, so x1 times x2 is your first thing, and then y1 times y2, and you end up with the same thing, it's just a different way of seeing the original question. All right, so that's our theory part. Let's try and use these in some questions. All right, so question 1. In an isosceles right-angled triangle, ABC, so I'm going to draw over here on the side, triangle, ABC. Now, the right angle, I'll leave that part. I'm going to put A, B, C. It says AB, the length of AB that is equal to 3 root 2. The length of BC and CA are both equal to 3, so these ones here are equal to 3. It doesn't specify there where the right angle is, but where must it be? The top. Okay, so up here must be where the right angle is.
So you have the two same angles adding up to 180.
Yeah, then it would be a triangle on the base there, if that was happening. Okay, we're also told, it says let vector AB be equal to little vector A, and BC, oh, I should draw arrows on there, so AB going that way, and A to B, and then B to C going that way, that's going to be little vector B, and then C to A is going to be little vector C. Okay, we have all our information in our diagram. We want to find... How do I know the right angles at C? Because it's isosceles with those 3's at the top there. It's not possible to have right angles down those bottom 2 angles because they both have to be the same. Isosceles would mean that those bottom angles have to be the same. And I couldn't put right angles there or I wouldn't make a triangle. So it has to be that one at the top. But while we're on that, since it's a right angle there, what are those other 2 angles on the... Yeah, so let's put those in. 45 here and 45 there. So first thing I want to find is vector A times vector A, and the second dot point that we have on the top of your page there is that is equal to vector A squared, or the length of A squared. Okay, then the length of A, just look at our diagram, the length of A is 3 root 2, so simply 3 root 2 squared. You square the 3, which is 9. You square the root 2, which is 2. So 9 times 2 makes 18. Okay. Part 2, I want to find vector A times vector B. And that looks very much like our formula at the top of the page, right? So to find that, our formula was length of A, length of vector A times length of vector B times cos of theta. But just be careful. That theta, what angle is that?
45.
Both wrong.
115.
Closer, but still wrong. 135. Okay, the reason, because is vector A and vector B, look at your two things there, they need to be tail to tail. They are not currently tail to tail. So vector A, vector B, I would need to move one of them, it doesn't matter, so maybe I move this one and slide it along that way, and I'm after that angle in there. Okay, which would be 180 minus the 45, so the theta would be 135 degrees.
That's why I'm going to just come to minutes.
Why are they tail to tail?
That's just how this formula works. They're always tail to tail. That's what I told you from the beginning. Okay, so if you want to see the derivation, there's a derivation for this formula in your textbook, but I didn't want to go through all of that. I didn't think it was worth the time. So I'm going to say that this is the length of vector A is 3 root 2 times the length of vector B is 3 times cos of 135 is what we worked out the theta had to be. Now, what did you say?
-1.
Is this the overall answer?
-9.
Should be -9 overall.
Yeah.
Yeah, I do.
Oh, cool. All right. This one does work out as a nice answer, so if you type that into your calculator from there, you would be fine. But you will need to try to leave answers in exact form most of the time. So sometimes you'll need to resort to your exact value triangles to work those out. So that's what I did. Not knowing, I didn't use my calculator, I went through and let's work that out exactly. So cos of 135 is the same as negative cos of 45, because 135 is in the second quadrant. So it's going to be, I'll go 9 root 2, if I times those two things together, times by negative cos of 45. Cos of 45 is 1 over root 2, correct? So it's 9 root 2 times by negative 1 over root 2. That's where the root 2's cancel out. And we're simply left with a -9. Okay, but just know I could have typed it in from the second line there for that one because it comes out as such a nice number. Let's do part 3. I have got some constants in there. So I have 3 times vector A, and that's going to be multiplied by -2 times vector C. Now the constants that are in there, we can just multiply those together, which is -6 lots of vector A times vector C. Now anytime we're trying to multiply 2 vectors together, we're going to use our formula. So this time we're going to leave that -6 out the front. Vector A times vector C is going to be the length of vector A times the length of vector C times cos of the angle between them. What is the length of vector A? Yep. What is the length of vector C?
3.
Yep. And what is theta?
Theta.
Yeah.
So you have to go for it.
It is this. It's 2 different vectors, but yes, it is the same as before. No. So we're doing A and C this time. So A and C are here. Again, we need them tail to tail. So you just slide the C down, so it's down there.
Oh,
and you put that angle in there. And you get will be
We're going to be
100.
minus C though, so it's the direction.
I know, I'm just moving that vector, I'm just rearranging my diagram to bring that vector down there, so they're tail to tail, and I want the angle between them.
Oh, so the minus and the vectors don't matter.
No, so it's like, no. Okay, so 135. So we already know that 135 is the -1 over root 2, so I won't go through all the extra steps again. So I have -6 times 3 root 2 times 3 times by -1 over root 2. And that also comes out to a nice number, 54. Because the square root 2's will cancel out again. Okay? Part 4. Okay, using our distributive law, I could expand out those brackets. So that would be vector C times vector B minus vector C times vector A. Vector B times vector C, looking at that diagram, what angle are they making? They're making a 90-degree angle. They're perpendicular. which means that that would just be equal to 0. Okay, so the vector b times c, that one in there, because we already know that those angles are perpendicular, that means that they're going to be equal to 0. You could go through the whole formula. It will still tell you if you use the formula, because you're going to get cos of 90, and that's going to make 0, but it'll save you some time if you identify that from the start. Okay, so it's going to be 0 for those first two, and then it's going to be minus, and now I need to do c times a, which is going to be length of vector c times length of vector a times cos of the angle in between. A and C, what's the angle in between A and C? Tail to tail, put them tail to tail. I already did this one last time, didn't I? It's 135. Okay, so it's going to be minus vector C is 3, vector A is 3 root 2, times cos of 135, and that all just comes down to a positive 9, correct? Okay, all right, part B. Without expanding the brackets, find vector A plus vector B plus vector C times by that again. What is vector A plus vector B plus vector C? Let's have a look at our diagram. Vector A, we start here, it goes from there to there. Plus vector B, plus vector C, we end up exactly back at the beginning, and it is 0. So that whole first bracket is equal to 0, and then, oh, maybe I should write that a little bit better. All right, I'll write like this. We have vector A plus vector B plus vector C must be equal to 0. So that means that I'm going to have, for vector A plus vector B plus vector C times by the same thing again is going to be 0 times 0, which is 0. Part C. Without calculating the left-hand side and the right-hand side, which means it doesn't want you to go and sub in values from the diagram again. So without doing that, explain why vector A plus vector B in brackets multiplied by vector C is equal to A times C.
C is perpendicular, so just cancel.
Correct. So let's show that. If I start with my left-hand side, I have vector A plus vector B multiplied with vector C. Expanding that out, I get vector A times vector C plus vector B times vector C. But vector B times vector C, we've already talked about them. They're the ones up the top of my triangle. They are perpendicular. So vector B times vector C is going to be equal to 0 because they're perpendicular. Okay, so that means the B times C is nothing, and I'm simply left with vector A times vector C, which was the right-hand side of that equation.
Wait.
Does it make sense?
I'm just trying to understand.
Are you understanding everything?
I hope so.
You hope so, I hope so.
But B times C equals 0.
It equals 0 because they were perpendicular vectors. So that's my little explanation, because it says to explain why, so I had to put that in there.
Why are perpendicular vectors 0?
Because looking at our formula, if we're multiplying vectors together, if I was to multiply them, I always have to times by cos of the angle in between them. And if the angle is 90 degrees, cos of 90 is 0. Which makes that whole, yes, remember from your curves, your cos curve?
Oh.
All right, on to next question. One more thing, okay, one more
I just
thing.
want to see that last question just for an extra second. The video because it's short.
Processing time.
A plus B times C equals A times C.
No.
A plus B in brackets multiplied by C. So I've just distributive law, I've times those out. So I've gone A times the C plus B times the C. That's all I've done, distributive law.
Ooh. A times B, A plus B times C.
A plus B is in brackets though.
Yes.
If you like, you can think of the C as being in front of the bracket and then you're timesing that through.
Then why is the B there? How does A, what the?
What's happening?
I don't know. Would it be?
Yeah. All right, question 2. The diagram to the right shows a triangle OAB. Let vector A be OA. So from O to A going that direction, we're going to have a little vector A over here. And from O to B going that way is going to be little vector B. They are position vectors, which means they're starting from the origin. You can see the O down there at the bottom of A and B. Find vector A, vector B, and AB as column vectors. So this for vector A and vector B, we're just writing down the information that we've been given from the diagram. So vector A over here on the left-hand side, the x-coordinate of the tip of that vector would be at -3. Yes? So that's going to be at the top here, -3. The y value of that vector is, can you see at the top?
Oh.
3 root 3.
Okay.
Yes, that's meant to be at the top there.
Oh.
So similarly, we can do little vector B as a column vector. Its x value is going to be +3 and 3 root 3 for the y value. Okay, so we're writing them as column vectors. Now, the one that requires a little bit more work is to find vector AB, which means I'm starting here at A and I want to go to B. Yes?
Why is there 3 root 3 on the A?
It's meant that 3 root 3 on the A is that y value there. It's just written a bit far over.
Oh.
Yeah. So vector from A to B, starting at the green dot at A, and I want to go to vector B. If I trace around my triangle to get to B, I need to turn vector A around, don't I? So it's going to be minus A plus B, or usually you'll see that written as B minus A. Which one of the tips is that it is always tip minus tail. So the tip of that vector was at B, so that's why it's vector B minus the tail end, which is at the A. Does that make sense when I say that? No. Tip minus tail?
Yeah.
Yeah, kind of?
No.
All right, let me start again. I'll explain that more detail then.
Yes.
So if I have a vector here, AB, and they are position vectors. Wait, Vince. If I have A and B that are position vectors, okay, and I'm wanting to find vector AB, the shortcut, which was one of the things that we did, I think, on the very first lesson, to finding that vector, is this is the, B is the tip of the vector, because that's where we're going to, and A is the tail of the vector, right? So tip of the vector, tail of the vector. And to find vector AB is just the tip vector, which is B, minus the tail vector, which is A, tip minus tail, if they're position vectors.
Yeah.
Oh my goodness, it's happening.
Okay, so now we know what vector B is as a column vector. It is 3 and 3 root 3. And I want to subtract vector A, which is minus 3 and 3 root 3. And when you subtract vectors, you just have to do the x's together and the y's together. So it's going to be 3 minus minus 3, which is 6, and 3 root 3 minus 3 root 3, which is 0. And hopefully that kind of makes sense, because that vector AB is all in the x direction, and it would have a length of 6 along the x and nothing in the y.
Right,
Yes?
Would this be an exact value triangle or the magnitude of 3?
Because the side's 3, no, that's not, it's not the one we usually use.
3 root 3, the bottom is
Yeah.
3, so you could just say,
I mean, you can always make it
Wait,
exactly.
make it
Okay. I think you have to pause the video again.
Which means
Oh.
this would be
Instinctively knew I could say that.
Alright, part B. Using the component formula for the dot product, find vector A times vector A. So using our column vector that we've worked out, that is vector A is -3 and 3 root 3. And we're just going to be timesing that by the same thing. When you times vectors, you times the two x values together, so you go -3 times -3, and then you're going to multiply the y's together. That's 3 root 3 times 3 root 3. That is, if you're interested in what rule I'm using here, that is this. Okay, so I've multiplied the x's together plus multiplied the y's together. Okay, that's that rule. Okay, that makes 9 plus 27 or 36 altogether. Okay, now we want to do vector A times vector B.
I will see if I can do this all by myself.
Yeah, you could just use the same kind of thing as what I've just done.
Yeah.
So A is -3 and 3 root 3. And B is the +3, 3 root 3. And same deal, I'm going to multiply them. So I do -3 times 3 plus 3 root 3 times 3 root 3. So this time it's a -9 plus 27. So that makes 18.
Yo!
Got it?
Yeah.
All right. So, next one, I want to multiply vector A, which is -3 and 3 root 3. And I want to multiply that by vector AB. What is vector AB? Look back up the top. Very good. 6, 0. And times away. So it's going to be -3 times 18 plus 3 root, sorry, I was saying the answer. Thinking ahead, well, it's times 6, which is 18, and 3 root 3 times 0. So obviously the 3 root 3 times 0 is nothing, and it's just -3 times 6, which is -18. All right, one last one. They're looking more and more complicated as we go, but we can do this. We want vector A plus vector B, and then all of that, because that's in brackets, we do that first, and then that needs to be multiplied by vector AB. So let's put it in round brackets for the round brackets around the outside. Column vector A is -3 and 3 root 3, and I want to add column vector B, which is 3 over 3 root 3. Close my round brackets, and I'm going to multiply that by vector AB, which again is 6, 0 that we found at the beginning. Now when we're adding, we add the top numbers together, which is -3 plus 3 is 0, and we add the bottom numbers together. 3 root 3 plus 3 root 3 is?
6 root 3.
Very good. Okay, we've done the round brackets. Now we're going to do the multiply by the 6, 0. And when we multiply the 0 times the 6, that's going to be 0. And then we add the 6 root 3 times the 0, which is also going to be 0. And so all that messy stuff just equals 0. Yay!
Does anybody else have to force themselves to not write one of those division lines?
Yes, yeah, I can
I've
understand.
accidentally written it that many times.
All right, I have added one more question here because I thought this was important. We haven't done any questions where we actually had to find the angle. Okay, and you will need to be able to do that. So here is a random question for you. If you want to find the angle between two vectors here. I've got 3i plus 2j is my first vector, and 2i minus j for my second vector. And I've put on the side there the formulas. The top version is literally just the formula that you've been given, leaving the cos by itself and dividing the length of A times the length of B across the other side. Okay, so that's our formula. But I've also included here, what does that mean? The reminder, if I'm multiplying these two vectors, it means I'm multiplying the two x values plus multiplying the two y values. So you could use that form as well. They do mean the exact same thing. So if I want to answer this question, to find the angle between those two vectors, cos of theta is going to be equal to, now I've got in my vectors there, for my x values, I've got 3 and 2. So I'm going to go 3 times 2 plus, now I multiply the y values, which is 2 times -1, over, now I need the length of A. Now you could do that separately, but the length of A, remember you're using Pythagoras' theorem, and I'm assuming A is going to be my first vector there. It's going to be 3 squared plus 2 squared. Does that make sense? Times by the length of vector B, which is going to be 2 squared plus -1 squared. You could find all of that exactly or as a decimal. You can do it as a decimal because we're going to an angle anyway. I don't have the decimal written down though. What I simplified it to, I had 4 on the top, and it's square root of 13 times square root of 5 when you simplify those surds. And multiplying the surds, that's 4 over square root of 65. That's still cos theta, so you would then need to inverse cos to get the theta by itself. You will inverse cos that fraction, and depends on the question. Sometimes they will say to the nearest degree, sometimes they'll say to the nearest minute. I made up this question, so I'm going to do nearest minute, so 60 degrees, 15 minutes. Okay?